Hi everyone, welcome to Radical Academy, and in this video we are going to look at linear programming. So in this video we are going to specifically look at how you can be able to come up or show what is called the feasible region. So in the previous video we looked at how you can be able to shade a line, how you can be able to draw a shaded, a solid line, and also a dotted line based on the inequality symbol. So that concept which we talked about are going now to be used in this same problem that you can see on the board. So without much further ado, let me not waste much time, but however, I would like you to support me, okay, by subscribing, liking, as well as sharing my videos. So let us now dive into that. So the question reads as follows. John and Joseph are brothers. Their aunt came visiting and gave them sweets. John's sweets were less than 6, okay? They were less than 6, while Joseph's sweets were less than 4. 6 times John's sweets, okay, combined with 8 times Joseph's sweets were more than 24. Okay, now when you look at this information that we have, it is now we should be able to derive, or we should be able to come up with the inequalities and then use the graph to show the specific area or where these 3 inequalities intersect, and then at the intersection, that is what we call a feasible region or the wanted region. So how do we go about that? First of all, the first question says, form 3 inequalities to represent the above information. And number 2, represent on the same graph the solution of the sets of linear inequalities formed and show the feasible region. So the first step is actually to come up with the inequalities, and 3 of them that we should come up with. Okay. Now what you need to understand is we need to find a way of showing this. Okay. So we are going to say let x represent the sweet. X will represent the sweet, represent Joseph, or rather John, okay, John's sweet, okay, and then part 2, we're going to say let y represent Joseph sweets, okay. Now we know that x will be for John and y will be for Joseph. So what is going to happen now is that we are going to say the first inequality is going to be that this x should be, okay, when you go back to the statement, they're saying John's sweets were less than, okay, so less than 6, okay. So that is our first inequality. And then number 2, saying that Joseph's sweets were less than 4. So y is less than 4. And now the last inequality is you have to look at this part. 6 times John's sweets combined, so we are combining with 8 times Joseph's sweets, were actually more than 24. So what is happening is that if I combine, okay, if I combine x, okay, plus y, it should be greater than 24. So that is the basic understanding or idea. Okay, so now we have seen how we have been able to derive that, okay. so we are saying that the first part, okay, the first part is x is less than 6, and the second part is of the inequality is y is less than 4, and then now the third part of the inequality is going to be, we said that x, if we combine, plus y should be greater than 24. Okay. Now we know that for John was actually 6 times, so you are going to say 6x plus, then for Joseph were 8 times, okay, so 8y greater than 24. Now the moment you do that, now, what you're supposed to do is to use now, so these are our inequalities that we have now. Now the second part is actually to come up with a graph, okay? So the graph can be simplified like that. Okay. Now remember that for me, for this graph to be actually something that is properly drawn, first of all, for this one, it is not actually possible for me to just graph this one. Now, we know how we tackle this question from the previous video. We said that, first of all, you have to come up with the coordinates, the points. So what you do is you are going to convert this inequality to an equation. So it's going to be 6x plus 8y is equal to 24. Okay? Okay, so from there, after you do this now, okay, you can divide throughout by 2. So you're going to have, just to reduce the equation, okay. Now from there, once you do that, you need to come up with a box, okay, and this box will contain just two pairs of the coordinate or the points. So to start with, for those that followed me clearly, you can actually refer to the previous videos for better understanding. So from there, you can just say when x is 0, so you do by inspection. When x is 0, you now substitute 3x plus 4y equals 12. So this is 3, open bracket 0, plus 4y equals 12. Okay, so meaning this is just going to be 4y equals 12. Okay. Okay, so meaning you divide both sides by 4, and y is just 3. So when x is 0, you get the 0 and plug it in the equation, and this is going to give you 3. So our y is 3. Okay? So our y is what? 3. So again, when you change now, when y is 0, so you put 0 there, then you use the same equation, this one. So you say 3x plus 4y equals 12, okay? Then, where there is y, you put this 0. So 3x plus 4, open bracket, 0 equals 12. So equals 12. So from there, you say 3x plus, so this is just 4 times 0. That's going to be 0, so you just ignore that. Then you say this. So from there, you divide both sides by 3. You'll be able to get what? 4. So meaning when our y is 0, our x is 4. So we do that. So from there, now we can go back to the graph. Now before you go back to the graph, then we have now the coordinates. you get the coordinate in this form. So starting with the number on top, so it says 0, 3, and also 4, 0. So we have to put those numbers on the graph, which is just an approximation, the graph that I'm going to use. So from there, we know that on the graph, this is 0, and then I can just use 2, 4, 6, 8, and this is the x-axis, okay? And this is the y-axis. So this is 2, this is 4, this is 6, okay? And then just for the sake of the negative part, okay. Now, don't worry about these numbers I'm actually putting there, but you can actually normally come up with the graph, okay? Just looking at the numbers that we have, okay? So in the box, we all have the large number is 4, and then on this part, we have the large number on this part. Okay, so we have, this is just 6, and that is 4. So on the x-axis, that is just the last number, okay? That is the highest number. And then on the y, the highest number is 4. So our graph can be as simple as that. So from there now, I'm going to plot these two coordinates. So how do we plot them? So 0, 3, so 0 is here, and then the 3 is a y number, y point. So 0 all the way up to 3, so 3 is in between 2 and 4. So this is just somewhere there. Then 4, 0. So our 4 is here, our 0 is there. So if you have this kind of a coordinate, since 0 it means you don't actually move any step. So our point will just be there. And then from there, you can just join these 2 points using a ruler. And then I'll start by saying, okay. Okay. So don't worry about my graphing, because I'm not actually using this on the actual thing. Now, because our inequality has this symbol, okay, there is no equal to, so the line should actually be dotted, okay? Should be a dotted line, okay? And then, which part do you shade? Because we are looking for the greater than part. So we shade the less than part. So between the above and below, so below is less than, and above on top of the line is greater than. So the one we are going to shade, the opposite of greater than is less than. So the less than is this part, okay? And then from there, we have the other inequality. The first one is, the other inequality is x is less than 6. Okay, so you go in the x-axis, then just draw a line across the 6 there. So also the line is dotted. Okay. So the line is dotted, okay? So you have to be very careful, okay? So now this, they're saying x is less than 6, so we shade the opposite. The opposite is a greater than part. And when I'm at 6, when I start going to the right forward, the numbers increase from 6, I go to 8. So this part going to the right, I don't want it, so that's the part I kind of discard by shading, okay? Okay? And from there now, the last part is this one. The other inequality is y is less than 4. So it says y is less than 4. We go to the y-axis. And in the y-axis, we just draw the line across the 4. But remember that the line should be dotted as well. Okay, so you do this. Okay. So you do this. just a bit there. Then I just do this. But for you, you have to ensure that you'll be using a ruler, so you'll be actually dotting it in advance. Okay. Now, once you do that, then which part of the line should we shade? Is it the upper part or the lower part? So the less than is actually when I'm at 4. When I start coming down, that is a less than part, which is a part I want. So the part which I don't want is a greater than. So when I'm at 4, I start going up, then the numbers increases. So what this means that the upper part is the part I'm going to shade because I don't want this part. Okay. Now this line has the equation y equals to 4. Okay. Y equals to 4, and this one on the x-axis is just x equals to 6. Okay, and the last part, okay, so the last part, this one just on the end of the line, it is 6x plus 8y equals 24. Okay. Okay. So now you can see. So now we can see now properly. We can see now properly that that we have come up with the feasible region. Now, this unshaded part, this part, okay, this is a part which contains all the solution for the 3 combined inequalities, okay. So, within this part is now where in the next video we'll be looking at what is called maximum and the minimum. So, at some point, if you're in business, you want to actually maximize the profits, and also at the same time, you want to minimize the cost of actually, or rather reduces on the expense, but increases on the profit earning. So this is what we call the wanted region, or rather in other books they call it the feasible region. Okay, so they use the letter R. Okay, so we use R to represent wanted region, or FR, which is just a feasible region. Okay, so this is how you can simply go about this question about linear programming. Okay, so in the next final video, we'll be looking at the maximum profit. Okay, so let's say, for example, how much sweets will actually maybe John or even Joseph need in order to maximize his profit. Okay, so linear programming is a mathematical model that is used in most of these businesses or companies that we see around us. So it actually helps us to understand, okay, how much do we need more employees, or actually, yeah, so it helps us to understand whether we actually need more employees or not. So that is what linear programming is all about, because it has what is called an objective function. Okay, so we need to have an objective. We need to have some objectives in order for us to make more money by cutting on the expenses. Okay, so that's all we have for you. Thank you so much for watching. Remember to support me by liking, subscribing, following, as well as sharing this video. So thank you so much, and I'll see you in the next video under maximum and minimum profit, or how to determine the minimum and the maximum. This is Radko Academy, and I'll see you in the next video. Thank you.